Okay, so I've pre-written the next batch of examples. So for example 6 is going to be a long one. There's going to be a lot of parts. We're going to go back to chemists and technicians. So there's 5 chemists, there's 7 technicians, and we're going to be making a committee of 4. And the committee is going to be randomly selected. So we're going to throw the names into a hat and we're going to pull out 4 of them. And I want to know what's the probability that the randomly selected committee meets some conditions. So the first condition is going to be what's the probability that it's all technicians. So the NS in this case, there's 12. We're choosing 4 of them. It's just going to be 12 choose 4. Now what do we want? We want them to be all techs. Now how many ways to be all techs? It's 7. We're choosing 4 of them. So that's going to be 7 choose 4. And the probability would be 7 choose 4 over 12 choose 4, which is 7 choose 4 divided by 12 choose 4, which is apparently about 7.07%. Okay. Now I want to know what the probability is that they're all chemists. Pretty much the same idea. It's going to be 12 choose 4 again. In this case though, what we're looking for, we want them to be all chemists. There's 5 of them. So that's going to be 5 choose 4. And the probability is going to be 5 choose 4 on 12 choose 4. That should be a smaller number. And it's 1.01%. Okay. Now we want the committee to be exactly 2 techs and to be exactly 2 chemists. I left myself a lot of space, but I don't think I'm going to need that much. No, I don't want the probability. First I want the number, the NS. So we're going to have nothing special there. It's still 12 choose 4. The special one that I started to draw, because my mind was getting ahead of my penciling or marketing, we have 2 techs and 2 chemists. And what we want is we want the 2 techs. There's 7 technicians, so it's going to be, and we're choosing 2 of them. There's 5 chemists, and we're choosing 2 of them. So it's going to be that times that. And the probability is going to be 7 choose 2 times 5 choose 2, all divided by 12 choose 4. Which is, I think I've recalculated this one. I think it's 42.4%. You know what, let me just double check it quickly. 7 choose 2 equals times 5 choose 2 equals divided by 12. Yep, 42.4%. Okay. We want to have at least 1 chemist here. At least 1 chemist. We're going to do this in 2 ways. So we're going to have our method 1. So for method 1, our NS is going to be the usual 12, and we're choosing 4 of them. The NA, it's going to be the total, which is 12 choose 4. And if we want to have at least 1 chemist, what would a bad one be? This would be total minus, and the bad, I'm going to kind of do this on the side, a bad one would be all techs. And the probability of it being all techs, I mean not probability, the number of ways for it to be all techs would be 7 choose 4. So it'd be 12 choose 4 minus 7 choose 4. And putting it together, we would get that the probability of getting that is going to be 12 choose 4 minus 7 choose 4, all divided by 12 choose 4, which is 12, choose 4, minus 7, choose 4, divided by 12, choose 4, is 92.93%. And that's the answer. Now, I did promise, that's kind of method 1, I did promise a method 2 here. So method 2 is we're going to say that the probability of getting what we want is 1 minus the probability of not getting what we want. Now what we don't want here is the 4 techs. So to put that another way, the probability of getting what we want would be 1 minus, and the probability of getting no techs would be 7 choose 4 over 12 choose 4, which gives you the same answer, 92.93%. Note that this essentially is just this kind of with these two divided. 12 choose 4 over 12 choose 4 is 1. It's another way of looking at it.